I'll just go to this quote here. Do you know who this guy is here? Right. This is a photo taken by Zach in 2000. So I think you know who that is. Do you know who that is? Ravi? How about this gentleman here? Who knows this guy?
Roy Johnson.
Dr. Roy Johnson, the guy who came up with the concept of durable resistance. Very lovely man, very smart guy. This is a quote of his that I took out of a book from 1993, where he's talking about major and minor gene resistance and durability. Okay, the most important thing, I'll just give you a minute to read that rather than me read it out. All right, so he's saying, yes, these minor genes and putting them together is important for durability, but major genes also play a role. All right? And in our experience, I think that's a pretty accurate statement. The problem is, you've got to know what genes are there. If a variety has 3 or 4 genes, you've got to know what they are, and you've got to know whether they're major genes or minor genes. Otherwise, you could end up, if you're using that line in a breeding program, selecting for the wrong thing and releasing a variety with only 1 gene. So here's an example, Jarvid. You mentioned that varieties carry both. This is selective. I picked some Australian wheat varieties in the year they were released in, and they carry both major and minor genes. Right? The minor genes are shown in blue. The major genes are shown in black. This is the presence-absence of this LR34YR18, which is also a minor gene, and also gives resistance against stem rust. So these are all stem rust genes here. Now, I have been selective in picking these, right? There's lots of other varieties, but I've just chosen these to illustrate the point. And they're not atypical. And we bred some of these way back in 1974, 84 and 86 and that. They all show very strong resistance to UG99 because of the presence of particularly these kinds of genes, SR2, SR13. 2426 was effective, both effective against the original UG99. SR12, 2436 with this LR34YR18. Anyway, so it's not unusual for a variety or a line that you're looking at that is resistant to carry both major and minor genes, seedling and adult plant resistance. So then the question becomes, how do we determine if a variety has adult plant resistance to a disease? How do we actually work that out? Cultivars with APR usually carry major seedling resistance genes. How can we separate the effects of those major genes from the minor genes, from the seedling resistance from the APR, right? What we've got to do is we've got to determine what major genes are present, what seedling genes are present in that line, and then we've got to test in the field and use a pathotype with virulence matching those seedling genes, so they're rendered ineffective. So this is what I was talking about before about opening the door. You've got a major gene and you've got a minor gene. You've got to get a virulent pathotype that's going to open that door so you can see behind it to see the minor gene resistance that sits behind it. Right? Or another way of doing it is to develop a segregating population, crossing the resistant one by a susceptible one. But the easiest thing to do, and we do this all the time in my lab when we're looking for adult plant resistance, if we want to knock out the major gene resistance with a virulent pathotype, put the line in the field with that virulent pathotype, open the door and see what's sitting behind it. So let's just go through an example of that. I think we've still got 15 minutes or so. Okay, good. So here's an example where we've taken 2 wheat cultivars. We don't know what seedling major resistance genes they've got. They've been tested with 5 stem rust pathotypes, and these are the infection types we've seen, okay? So cultivar A is resistant to all 5 pathotypes and it's giving a 2 infection type. I'm sorry?
It's low.
It's low, right? Incompatible. But so we can talk about the resistance in the variety. So this one's resistant. Cultivar B, on the other hand, is giving a fleck to the first 2 pathotypes, but it is susceptible to the 3rd pathotype. It's giving that fleck reaction to the 4th pathotype, and it's susceptible to pathotype number 5. So you remember yesterday, what I'm saying here is that the first variety is giving a 2 infection type like this, and the second one is giving a Fleck reaction like this to some of the pathotypes but not all. Okay, different phenotypes. When we look at our differentials, we look at our genetic stocks that we know, the genes that are in them. We have a differential called CAV-CAS that carries this SR31 gene that we've talked about already, that was sitting on the 1B1R translocation. And it's showing the same pattern of response to cultivar A. So on the basis of that, we would postulate, right? It's not proof, but we would postulate the presence of SR31 in cultivar A on the basis of the infection type and the fact that the gene is effective against all of those 5 pathotypes. It's not proof, but that would be the postulation.
Is it right to say postulation is not authentication?
It's not authentication. We could test these with a 6th pathotype and we might find that cultivar A is susceptible and CAV-CAS is still resistant. That would tell us it's not SR31. All right? But the gene postulation is quite a powerful thing. And if you know the infection types and you know the genes, you can be pretty confident you're right. Not always, but our differential for SR5 is reliance, and you'll see the infection type and the specificity is the same. So based on that, using the gene for gene hypothesis, we would postulate the presence of SR5 in cultivar B. All right, so now we've taken 2 cultivars. We did not know what seedling genes they carry to stem rust. We've done the test and we've postulated those 2 genes as being present. So we've got a bit of an understanding of what might be present in those 2 varieties. Okay, so I've just summarised that there. I said cultivar A carries SR31, cultivar B carries SR5 based on gene postulation. We put them both in the field, test them with stem rust, and both cultivars are highly resistant at the adult plant growth stage. What does that mean? Does it mean they carry adult plant resistance? They're resistant as adult plants in the field. Does it mean they carry adult plant resistance? They're resistant as adult plants. Do they have APR? It doesn't. Right? It's not possible to tell what that field resistance is unless we know the virulence and avirulence of the pathotype present in the field nursery. So if we had a pathotype in the field that was avirulent on SR5 and SR31, we haven't opened the door. We've still got the door closed. We're looking at the effect of SR5 and SR31 because the pathotype is avirulent. What we need is a pathotype. In order to assess the presence of adult plant resistance in cultivar A, we need a pathotype virulent on SR5. And in order to assess the adult plant resistance of cultivar B, we need a pathotype, I'm sorry, I said that round the wrong way. In order to assess the adult plant resistance of cultivar A, we need a pathotype virulent on SR31 to open the door. To determine the presence of adult plant resistance in cultivar B, we need a pathotype virulent on SR5. Javed, sorry, you were going to say something?
But if one don't know about the genes, or if you don't have information regarding gene postulation in a cultivar, then
it's not possible, right? And you might.
Isn't it good to complement the seedling studies along with field studies?
That's what we're doing here. We're testing them in the greenhouse to start with, as seedlings, and then we're putting them in the field.
If a race A, for example, is virulent at seedling stage, wouldn't it be wise to use it for adult plant discrimination?
Exactly. So, and in fact, you don't even really need to know what gene is present, right? So I've got postulations here, but provided you tested cultivar B with this pathotype, or this pathotype, you could then do an assessment of adult plant resistance. You don't really need to know the gene is SR5, provided as a seedling it is susceptible, and in the field you use the same pathotype on the same line, then you can assess the adult plant resistance. All right, so we need to test in the field with a pathotype with virulence matching the seedling gene to open the door. Now, for me, I can do that in Australia with cultivar B. We've got lots of virulence for SR5. We've got a lot, just about, I don't think we've got a virulence for SR5 in any of our current pathotypes that we get from the field. So that's easy. We can put cultivar B in the field, inoculate it with one of our SR5 virulent pathotypes and see what it does. I can't do that with cultivar A. We don't have virulence for SR31 in Australia. So I'm going to have to send that to Kenya or to South Africa and get that tested in the field there, because I can't knock out 31. I can't open that door. So I'm going to have to send it to these guys to test in the field with one of the UG99 pathotypes to see whether there's adult plant resistance present or not. All right, so testing in Uganda, Kenya, Ethiopia, South Africa, for example. If we do that, all right, so let's say I send the line with SR31 to Zach, and he tests it in his nursery in the field with UG99, and it is susceptible as an adult plant. We say it doesn't have adult plant resistance. If it's resistant as an adult plant, then clearly it carries adult plant resistance. So this is how we separate the effects of major gene and minor gene, or seedling and adult plant resistance. You have to have those correlated tests of seedlings and adult plants with pathotypes of known virulence.